At the end of this lesson, you'll be able to apply the mean value theorem on an indicated interval. Let's first of all take a look at the mean value theorem. Here's what it states. If f of x is continuous on the closed interval a and b, and it's differentiable, so very similar so far to the mean value theorem, the Rolle's theorem, differentiable, then there exists a number c in AB such that f prime of c is equal to f of b minus f of a all over b minus a. Okay, just in case that's not looking familiar to you, basically what this theorem is saying is that at some point c, the instantaneous rate of change, or the derivative, is equal to the average rate of change, or the slope. So notice this first side, that's the derivative. The second side is the slope, or the average rate of change. So if the mean value theorem holds, if a function is continuous and you can take the derivative, then there will be somewhere where the derivative will equal the slope. So let's go ahead and see if we can apply it. It says to apply the mean value theorem to f on the interval. In each case, find all values of c in the interval. So basically what we need to do is we need to figure out where would the derivative equal the slope. And first of all, we need to make sure it applies. If I make sure it's continuous, and this function, let's just make sure it's continuous. It is a continuous function. There are no places where there is a denominator, so there's no places where the function is undefined. The second one is we want to make sure it's differentiable. So if I take the derivative, actually before I take the derivative, we could use the product rule, but I'm going to choose to just distribute the x to all three parts before I start. So I'm going to get x cubed minus x squared minus 2x. And if I take the derivative, I'll get 3x squared minus 2x minus 2. And then from here, notice it is differentiable because there's no place where that derivative would be undefined. So based on that, I want to find out at what point the derivative is equal to the slope. So first of all, I've already found the derivative. So step one, find the derivative, which I did. Okay, step two is actually to find the slope. So if I want to find the slope, I notice that my x values are -1 and 1. So I need to actually go find the y values. I'm going to go back up into the original function to find the y values. And I think I will go into the simplified version to get my y values. So if I plug in -1, I'm going to get -1 minus 1 plus 2. That should give me 0 when I plug that in. And then if I put 1 in, I'll get 1 minus 1 minus 2. That should give me -2. So the slope, y2 minus y1 over x2 minus x1, that will give me -2 over 2, which gives me -1. Okay, so the mean value theorem states that somewhere the derivative will equal that slope. So the next thing I'm going to do is actually take the derivative and set it equal to the slope. And now from here, it's just going to be a solving for x problem. So the first thing that I'm going to do is make this equal 0. So I'll get 3x squared minus 2x minus 1 equals 0. And then I notice that I can factor it. It's a trinomial. I'm going to use the magic number trick. Hopefully you're somewhat familiar with this. When there's a coefficient in front of the x squared, 3x, 3x, I'm going to divide out a 3 when I'm done. Basically, I'm going to take the 3 times the -1, that gives me -3, and then I'm going to be thinking to myself, what times what would equal -3, but add to give me -2. I'm just going to list some choices. So -3 times 1, -1 times 3, I think that's about it. And you'll notice -3 and +1 will add up to -2 in the middle, so I'll have -3 plus 1. And then I do have to divide the 3 out of one of the parts, and I'll divide it out of this one. So I'll get x minus 1, 3x plus 1, that still equals 0. And I would like to find the values. So I notice that this one would be x equals 1. This one, if I set it equal to 0, I'll get 3x equals -1. So x would equal -1/3. Okay, and I basically found my answers, but it did say to find all values of c. So now I'm just going to come up here and actually will write c is equal to 1, and it would also equal -1/3. One thing that I do want to check is just to make sure that both of those values are in my interval. 1 is in my interval, and -1/3 is also in the interval. So those would both work. All right, let's try another one. Again, we want to make sure, first of all, that the mean value theorem applies, it needs to be continuous and differentiable. So we'll go ahead and find if it's continuous. There is a square root, so I know that I can't have anything that is less than 0, but since anything less than 0 is not in my interval anyway, it is continuous on the interval. The second thing, it has to be differentiable. So let's go ahead and take the derivative. If I take the derivative, another way of writing the square root of x would be x to the 1/2. So if I take the derivative, I'll get 1/2 x to the negative 1/2. And then rewriting that, that will equal 1 over the 2 square root of x. Again, x needs to be anything bigger than 0, and we're fine because anything smaller than 0 is not in my interval anyway. So I'm good to go. So now I need to apply the mean value theorem. There's somewhere where the derivative, so step 1 is finding the derivative, which we already found was 1 over 2 square root x. And now the second thing is to find my slope. Again, we know our x values are 1 and 9. I'm going to go back into the original function. If I plug 1 into the original function, I'll get 1. If I plug 9 into the original function, I'll get 3. So if I calculate the slope, 3 minus 1 over 9 minus 1, I will get 2 over 8, which reduces to 1/4. Okay, the mean value theorem states that somewhere the derivative will equal the slope. So now I'm just going to set those two equal to each other. Okay, the easiest way I know how to work a problem when I have two fractions set equal to each other is to cross multiply. So if I do that, I'll get 2 square root x equals 4. And then we'll divide both sides by 2. So I'll get square root of x equals 2. And then to get rid of a square root, we square both sides. And I will get x equals 4. And I just want to make sure 4 is in the interval, so I'm set. And it did say to find the values of c, so we'll just change that x to c, and we are good to go. All right, one more example. 2 stationary patrol cars equipped with radar are 5 miles apart on a highway. As a semi-truck passes the first patrol car, its speed is clocked at 55 miles per hour. 4 minutes later, when the truck passes the second patrol car, its speed is clocked at 50 miles per hour. Prove that the truck must have exceeded the speed limit of 55 at some time during the 4 minutes. Well, what I'm going to do, because I'm guessing this is a mean value theorem problem, I'm going to find the average speed of the car in the interval, and to get the average speed, or we could call this the average velocity. If you can think back to physics at all, an average is just calculated by your change in distance over your change in time. So if we look at this, we traveled this patrol, the semi-truck traveled 5 miles, and how long did it take? It took 4 minutes, and if we're dealing in miles per hour, 4 minutes out of 60 is actually 1/15 of an hour, so it took 1/15 of an hour. So 5 divided by 1/15 is 75 miles per hour. So that was its average velocity. Okay, assuming that this is a continuous function, the car is not making any sharp turns or anything like that, just this truck is just nicely going on the highway, then the mean value theorem tells us that there is somewhere where the average speed is going to equal the instantaneous speed. So we can say, due to the mean value theorem, if the average speed, oh goodness, speed was 75 miles per hour, then there must be some time when the instantaneous speed, or the actual speed, the truck's actual speed was 75 miles per hour. So the truck would be busted based on calculus alone. And hopefully now you know how to use the mean value theorem on an interval.